Hello, everyone, and welcome to today's webinar, Principles of IPM and Why They Matter, presented by BioWorks. I'm Robin Sittberg of Meister Media Worldwide, and I'll be moderating the webinar today. The webinar has been approved for a half CEU credit in Integrated Pest Management from CCA. It's important to remember that at some point during this webinar, an attendance poll will be sent, and you must respond to it to receive credit. If you respond once the webinar is finished, you'll receive an email with the QR code for reporting your credit. You simply scan the QR code and submit it. Please do not close your browser before the event is fully ended, or you will not receive the email with the QR code. This is also for viewers who are watching the archived webinar. We will have time for some questions at the end of the webinar, so if at any time during the presentation you'd like to ask a question, just type it in your question pane and click submit. You can do this at any time during the webinar, and we'll answer as many questions as we can at the end. Before we begin, I'd like to introduce today's speaker, Dr. Erfan Vafaie, and he is the Field Development Manager at BioWorks, bringing more than 12 years of expertise in integrated pest management with a focus on entomology. Previously, he served as an extension program specialist at Texas A&M AgriLife Extension, where he designed and executed research experiments for the greenhouse and nursery industry, both in controlled environments and on-site trials. Dr. Vafaie has a strong track record of translating technical research into practical educational resources for growers and other stakeholders. He earned his PhD in entomology from Texas A&M, and now I am pleased to turn the program over to Dr. Vafaie.
Thank you so much, Robin, for that very kind introduction. And thank you, everyone, for joining this webinar today. So as Robin mentioned, today we're going to be talking about principles of IPM and why they matter. And to really jump into the why it matters at the beginning, I want to first jump into a little bit of quick history. I'm sure many of you are already familiar, but for those of you that aren't, this may be a nice first time to understand where IPM comes from. In the 1940s and 60s, we had what was known as the Green Revolution. The father of said revolution was Dr. Norman Borlaug from Texas A&M. And he was said to have saved billions of people from starvation. I should say that whole revolution, but he was, again, that father of that revolution. And what was some of the outcomes of that revolution was these high-yielding varieties of cereal grains, expansion of irrigation infrastructure, and we also had this distribution of seeds, synthetic fertilizers, and pesticides to farmers. So very quickly, we went to being able to do this very large industrial type ag that we see in this day. At the same time as this, we also had globalization, where every single dot here that you see on this particular map represents a particular shipping container that is moving thousands and thousands of containers, some of which are plants, and some of those plants are carrying plants, and some of those plants are carrying insects, right? And so we sometimes have the movement of these, what we call invasive species. So maybe some of you have heard of Thrips parvospinus as kind of one of the more recent Thrips invasive species that's wreaking a lot of havoc. And so there's a lot of these. Actually, the list is pretty big. You can see there in the background scrolling, and you will be tested on this in the end to get your CEU. I'm just kidding. You don't need to look at all those, but there's over 502 records of invasives. Again, high impact insects that are not from our particular territory with billions of dollars of economic impact. And I say billions very conservatively because you think of spotted and lanternfly, which was introduced not too long ago, its annual impact in Pennsylvania alone is currently $50 million. That's its estimated economic impact. But that's okay, because we solved this issue when we invented DDT, powerful insecticides, safe for humans. At least that's what that sign says. You can see we fumigated our children, and so that was no longer an issue. And to DDT's defense, this was the time of malaria vectoring mosquitoes were causing a lot of issues, even in North America. And this DDT helped really eradicate that issue. But during this process, we also learned about insecticide resistance. We learned about environmental impact and a whole lot of other things that are now almost natural to our pest management kind of background. And so there was this book written by Rachel Carson, known as Silent Spring, very famous book that was very influential in that time. And there's this famous quote that says, "Why should we tolerate a diet of weak poisons, a home in insipid surroundings, a circle of acquaintances who are not quite our enemies, the noise of motors with just enough relief to prevent insanity. Who would want to live in a world which is just not quite fatal? All right, and so this book and a movement around it help essentially establish the EPA and these IPM programs, integrated pest management. Now, however, since a lot of IPM at that time was focused on large field ag, there were ways of systematizing IPM. One of which was Dr. Vernon Stern here created this. We have both economic threshold and economic injury level. Right? Over time, as your pest population increases, there's a certain level at which if you don't spray, now the damage caused by the insect is more costly than the cost of spraying for that insect. So you have to do that to decrease it, and there's this equation to explain it. And this was great in things like cotton and corn, where they are very large fields. It is commodity set prices and very easy to work with. When we're talking about smaller horticultural or specialty crops, this system doesn't work quite as well. So we have to look at some best management practices. So that brings us to our objectives for today. We're going to talk about best plant sanitation and cultural practices to consider, how to promote healthy plants, and lastly, best pesticide application practices. These things would three things would really help establish the foundation of a good IPM program at any establishment. And before we kind of kick into full gear there as well as just some background into IPM, if you've ever seen a presentation or even read a textbook on integrated pest management for arthropods, so insects and spider mites, you'll know it always starts with a good cultural sanitation program, physical, mechanical, then biologicals, and then chemicals, your last resort. And this way you can actually maintain your chemicals, have less pesticide resistance when you rely on it last instead of having it at the beginning. And if you've ever seen the disease triangle here, you can see you need favorable environmental conditions, the virulent pathogen organism, and the susceptible host plant in order to get the disease symptoms. So you can actually have the pathogen, right? You can have the pathogenic organism around, but if the environmental conditions aren't favorable, you will not get the disease, which is then the actual symptoms. So keep that in mind as we go forward, and always start with identification, right? We're not going to go into detail with ID here because that could be a whole webinar or two in its own. I do have a couple QR codes here if you'd like to scan them. One is an excellent resource for identifying different types of larvae. The other one is for identifying a number of different types of plant pathogens. It's actually a presentation I have created a few years back. And so think of it as kind of like a manual that has a good number of pictures that you could use to reference for some common pathogens you might encounter. Now, don't blame yourself in terms of identification being challenging. Even as experts, we have challenges. There are currently 1.2 million species that we have described, right? So anytime we identify something as a new species, someone has to describe what it is, what are its characteristics, how is it different than the other species to really make it a new species. But it's estimated that there's 8.7 million species, right? So there's a lot more species that have been described, and about 59% of those are insects and 7% other arthropods. So you can see a huge number of them are insects and insect-like things. So it's not your fault if you're finding that difficult. And I'm going to say that again. It's not your fault. And if you haven't seen Good Will Hunting, now's a good time to pause this webinar, go watch that movie. Great movie, so you can just understand that reference, and then you can come back and watch this recording, all right? So again, very difficult to identify, and that's okay. That's why you have manufacturer reps that are here to help you. That's why you have extension agents. You have plant and disease diagnostic clinics in many different states that are here to help you identify things. And then on top of that, there's a good scouting program, which is you want to do a good randomized sample. You want to keep eyes on things, even though they might look healthy. Now, in this case with this boxwood, you might see there is a little bit of a disease or a pathogen on a plant there. And when we look at even the healthy plant there, right? So in this case, I'm only looking at the healthy plant. I'll make it a little bit bigger so you can see. When I take a closer look at a healthy plant, even that has, when I pull from the roots, I get the telltale signs, pun intended, rat tail symptoms of Phytophthora, right? So even though that's the healthy plant around this diseased plant, I'm not making an assumption that the rest of these are healthy. And actually, a few weeks later, all of these plants started to see some decline. So by catching it early, even earlier, you're able to prevent a lot of those issues from occurring. So you really need to scout. Don't make assumptions. You want to be curious, not judgmental. And if you haven't seen Ted Lasso, you can pause this webinar right now and go watch Ted Lasso on Apple TV. Also a great show. But be curious, not judgmental. In this case, we're talking about our plants and their symptoms. Take a closer look at your plants to make sure that they are actually looking healthy. Now, instead of, again, looking at economic thresholds and economic injury levels, what I recommend in a horticultural specialty ag type situation where you have smaller plots or smaller greenhouses is to look at your potential entry points of disease, pathogen, or insects, arthropods, and have management strategies around them. So in this case, we're talking about incoming propagated material or contaminated growing surfaces, media and pots, crop residue and weeds, irrigation system, infected tools, nearby unmanaged habitat, people, right? On our hands, you can carry a lot of pathogens just going from one house to the next. Spider mites can just float around in the air, almost like ballooning, and they can move around from greenhouse to greenhouse. They can get onto our plants. And so, a greenhouse map might look something like this, where, again, you have a good idea of where your water is flowing from, where are the areas of unmanaged habitats, where are the areas of highest risk. And some of you may be familiar with SANC. It is Systems Approach to Nursery Certification. It is looking at the entire system. It is, I would say, a really structured way of looking at applied IPM in horticulture. And this is put on by the National Plant Board. So if you go to that website, sanc.nationalplantboard.org, you'll find resources. Even if you don't want to get SANC certified, that's a little redundant, SAN certified, then you can go there and at least pull from their resources, right? And learn how to apply some of those principles. And it's really based on HACCP, right? Which was developed by, I want to say, Pillsbury back when they were designing food for spaceships. And then to make sure, for example, that the food had no crumbs, because those crumbs floating in space can become a choking hazard if you breathe it in really easily, right? So they have a number of critical control points, identifying those hazards and best management practices. And these are really important even to today, because if you saw in the news recently, you see there was a new bacteria discovered on a Chinese space station, right? So if there was much better HACCP, then that could have been prevented. And so always critical to look at those critical control points. And so one potential way, or this is just an example of making this very practical, very documented, is to have a manual, right? So there's Rick and Morty's Wacky Tacky Greenhouse as an example. We have the personnel, and this is not a printed document, but a live online document, because these things may change. We have our IPM manager and our scouts listed, when it was last updated. And we have, as an example here, what we do in our receiving. This is a specific doc C, right? So keep plants in quarantine, receiving for 2 weeks prior to it going out. It has to be looked at by the IPM manager before it's released to the rest of the operation. So again, this is a way you can prevent stuff from infecting everything else and becoming a much bigger headache, right? They're inspected, and then they'll either get flagged, they might get destroyed or sent back depending on what's there. And there's some cultural practices, like herbicides to be sprayed every 3 months on the external perimeter of the docking station, so on and so forth. And then you create more specific schedules then around these to actually follow it. Another really good reason why you might want to document these things, at least from my experience in our industry in the last 5 to 10 years, has been there's a lot of turnover. And when there's a lot of turnover, it's hard to maintain a consistent program. And if you have something at least documented, or a document building, it can be something that's built up and have some continuity of your crop protection program, rather than it collapsing every single time there's someone moves on. And then you might have several different houses or structures, and they might be slightly different in what are their hazards and what are the best management practices. You might have imported propagated materials versus internally produced. You might have standard production houses, mother stock plants, production houses near unmanaged property, right? So all of these might have their own set of things that are specific to them. And then you might have some general rules, some general critical control points that you are also trying to manage. So these pest management, we call them pest management units. Each of these, say, structures, or in this case is greenhouse 1 through 10, standard production houses. They have similar growing conditions, similar pest pressure, similar pest management practices. So what do these critical control points and best management practices look like? So as an example, and photos are, you can include photos as well. This thing could be a PowerPoint, right? It doesn't have to be a Word document. But one example is algae on the floors, right? And please raise your hands if you have algae on your floors. Yeah, okay, I can't see you guys. I'm assuming there's some of you with hands raised, right? And that is a potential issue, right? Not just for slipping when it's wet, it can be very slippery, but it's a source of fungus gnats and potential movement of Phytophthora. So again, we can pretend like that's not an issue, or say labor is too difficult to come by to manage our algae. But if you don't, now you have to spray your plants with fungicide more consistently, which also costs labor, right? So you can do some work up front to help manage the situation. So prevention might be monitor floors weekly for overwatering and adjust accordingly. Fix leaky irrigation lines within, put a certain timeline. And I know for some of you, you recognize this as an issue, but maybe management doesn't see that as a critical thing that needs to be worked on. By putting this in here, you establish that the leaky irrigation is tied directly to movement of Phytophthora. The reason why now your pesticide guys have to spray more frequently for Phytophthora, and that you have the number of losses you have, is due to the fact that we're not fixing our leaky irrigation, right? So now some of these things that don't seem as high priority, you can give priority because of the hazard that causes. Spray floors with a broad spectrum cleaner between cycles, hydrogen peroxide, Purpose Plus. As an example, we have a product that's called Purpose Plus, 33% hydrogen peroxide. Works very well as a preventative to maintain low amounts of algae. If you already have a thick mat of algae, there's nothing that's going to clean that except for a shovel, right? Like some hard labor. But if you're trying to prevent that algae from growing, a regular spray of this Purpose Plus will really help reduce that algae. And our product is unique in the market in that it has a proprietary stabilizer in there to stabilize the hydrogen peroxide. Some other companies might use something like peracetic acid, which smells like pickles, like a very strong pickle smell. So if you've ever sprayed within your greenhouse and had that very strong pickle smell, you would like to move to something that smells like fresh, like oxygen, right? Is what our product kind of smells like. Then consider this Purpose Plus as an excellent thing to add into your program. So another one, critical control point might be greenhouse entry points, the doors, swamp coolers, and other entries. So risk, source of flying insect pests. That could be adult thrips, that could be whiteflies, that could be adult winged aphids. Right? So there's a number of winged adults that can be moving in through those entry points. So what are some best management practices? Prevention. Keep greenhouse doors closed at all times. Yellow sticky traps. You can see here they've used yellow sticky tape actually around almost like the perimeter of their crop at that entry point to try and reduce those numbers, not just monitoring, but actually reducing those numbers. And crack holes in the poly, sealed with some trusty duct tape. I was being a little bit cheeky here, but duct tape works really well. Any holes, right, that they could potentially enter through. They can sense that heat. They can sense the chemicals, the plants, their antennae. That's how they find crops. So make sure you seal those holes so they can't get in. And then for biological and chemical control, you might list in a separate appendix what all the biologicals or chemicals they may consider, how they need to be applied, and we'll get kind of into best application practices later. And another product you might consider for this type of situation, we just launched this bad boy beginning of June, fresh on the market, is our Principal WP. It's our own proprietary Beauveria bassiana. We have been selling Beauveria bassiana for over 20 years. So any of you that have worked with us in the past know that we are experts on this particular active ingredient. And this product has been formulated based on those expertise. So it is the new industry standard. Imbovariobaciana if you're looking to manage soft-bodied insects, flying insects, so on and so forth. All right, another critical control point, weeds/discarded plants. And you'll see here in this case, these are discarded plants thrown into these bins at the end. What are they? Source of flying pests and airborne pathogens. All right, so just by moving these things and sitting them here, you can still have spores that are coming off them. You can still have flying insects that are noticing, this thing's wilting. This isn't as fun of a party anymore. I'm going to go somewhere else. So prevention, isolate, and discard the plants within 2 weeks of cull determination. The number of times I have seen, and unfortunately, quite a few of them out of business now, where they can't take the time to remove those old plants. They're sitting there for weeks, if not sometimes months on end. And they're just a source of pests. No one's monitoring those things. No one's making sure that they're in check and they're not isolated. Take the time to remove them. Otherwise, it's a constant uphill battle. All right. Or a lid. Something as simple as a lid will help contain them and prevent them from moving out. You got black bins with a black lid, you'll cook them. So that can also be a very effective way. Another critical control point, new transplants. So here we've got brand new poinsettias stuck. Raise your hands if you're growing poinsettias and have your cuttings just coming in right now. Great, still can't see you. But I know a lot of you maybe are growing poinsettias or you're sticking some other young transplants. And these are when they're most disease susceptible. All right, and this is when you can get those root pathogens. So best management practices, sanitize pots, benches, or the soil media, whatever it might be. Solarization, for example, in fields for cooking that soil. And then checking your watering schedule to make sure you're watering effectively. In terms of biological, use trichoderma to promote root growth and protect from root pathogens. We'll touch on that later. And then you might have some control, some chemical programs as well in your sleeve. All right, so we've kind of talked a little bit about this plant sanitation cultural practices, at least how to start establishing a very practical program. Now, how do you promote healthy plants? All right, so I think all of us know that even plants can get stressed too. And it can be abiotic factors. These are things that are not biological. They are heat, cold, drought, flooding, soil pH, all these other non-biological things, or it could be pests, disease, and weeds. Both of those things can cause stress. And earlier, when we were talking about the disease triangle, one of the things was environmental factors, right, that will increase plant susceptibility. So that's a lot of the time is abiotic factors. You might notice either hottest time of the year when it all of a sudden gets really hot, it can trigger certain pathogens, or it might be really rainy or a short period of drought. It can also all of a sudden trigger those pathogens. And that's because we have created stressed plants, which is a susceptible host plant. All right, so how does that affect plants? These abiotic factors will have an impact on metabolism, cause inconsistent rooting, poor growth and development, plant death, whereas biotic will reduce growth and photosynthesis, the ability for that plant to take up those sun rays for its energy powerhouse, poor performance in production or post-sale, and impact aesthetic qualities. So, and it's always important to look at nutrient deficiency symptoms, and not just the foliage, but also below ground at the roots. So you might see here, this is the control, and in low nitrogen, you'll see most of those symptoms are actually above, right? And you get these long, straggly roots as well. If you're low in magnesium, you'll see it looks fine just up above, but there's a lot less root mass. So it's important to look at kind of all components of the plant on a regular basis. And what we want to do is create a very strong plant. We create a strong plant, it'll better, believe it or not, be much better at resisting against pathogens. It'll be much more robust against abiotic stressors and do a lot better against insects as well. So how can we create a stress-free environment for these plants? It might be things like shading, ground and pot covers, more controlled irrigation. All these are things that you're very familiar with, including all the way down to plant nutrition. In plant nutrition, it's actually very interesting. Even overnutrition, right, can be a cause of stress. So there was a few studies actually done that demonstrated many greenhouses and nursery ornamentals are over-fertilized. So they're maybe using the recommended amount of fertilizer on the fertilizing package, but is actually quite a bit higher than what the plant needs, which can result in leggy plants and soft growth, increased susceptibility to diseases and pests, which we'll touch on here in a moment. And those high salts can cause kind of leaf burning here on the edge as well, as you see on the right side. So here's an example of a study that found that with increased nitrogen, rhododendrons had all the plant properties you're looking, all the plant characteristics you're looking for were improved. However, it also, for the cultivars that are already susceptible to Phytophthora, it increased their incidence of Phytophthora, right? So by having more nitrogen, it also caused them to become more pathogenic. And here's another study that you can see on the bottom there are just different treatments. And the y-axis is the number of two-spotted spider mites, Tetranychus urticae, and that's the eggs, right? So egg production over different treatments. And you can see on the very far left bar is the high fertilization rate. You're getting almost about, let's say 1,100 spider mite eggs counted per leaf. And then if you go just one bar to the right, that's empty. That's low fertilization. That's 50% the amount of fertilization of the high, but they were still finding this, in this case, was chrysanthemums. The chrysanthemums were just the same size, same number of flowering, everything. But just by reducing the amount of fertilizer, you can see the number of spider mites went down almost in half. Now, if you go to the far two bars on the right, that's bifenazate. You spray bifenazate with high fertilizer, yeah, you maybe cut down that population of spider mites by about a half, but there's still a lot of spider mites. It's not until you put your fertilizer in check, where it's low fertilization, and you have your, in this case, a miticide that puts that population down. In those middle two bars, you use a predatory mites. So maybe some of you have tried beneficial insects before. Some of you have had great success. Some of you maybe haven't. And one of the reasons might be because there are other factors that are impacting their ability to be successful. You can see that the predatory mites with low fertilization actually perform just as well as bifenazate. And not all fertilizers are created equal, right? There are synthetics that are very quick pop nutrients, and there's organic on the right that are a little bit more sophisticated, take longer to break down, include things like amino acids. And there are these products on the market called protein hydrolysates, and that's just a fancy way of saying that it's some type of a protein or fertilizer produced through chemical, thermal, or enzymatic breakdown of something, of some kind of a plant. So, and the composition is mainly peptides like proteins and free amino acids. And if you think about maybe you've taken vitamins before, maybe you've taken amino acid supplements when you're exercising and you're just set on really wanting to build those muscles, and you are looking at specific amino acids to help build those muscles. That's what this basically is. Even plants need that same type of thing. And there's this particular review, if you scan that QR code in the top right and want to read in more detail, has basically looked at all the studies on protein hydrolysates and their impacts on plants, and found that they can help with seed germination, increase shoot and root growth, fresh and dry biomass. It can help with plant growth and productivity, increase in fruit quantity and weight, fruit and vegetable quantity, and is a good biostimulant. It can actually modify the microbial community, and has even been found to elicit plant defenses, which results in suppressing downy mildew. So we have a product called On Guard. So if we're talking creating a healthy plant, this On Guard really helps boost the plant defenses, helps give it the enzymes and peptides that it needs to really be strong, and also helps feed other beneficial microbes in the ground. This product has been a very helpful one to introduce into grower programs that are also having difficulty with nutrient uptake. The nutrients are there, but the plants aren't taking it up. This particular product can help with nutrient uptake efficiency. And again, that helps create this nice, strong, robust plant. And I also want to talk about bacteria and fungi for plant health. Anyone who has seen The Last of Us or played The Last of Us, the games, is maybe familiar with a fun little fungi known as giving you a chance to answer. Anyone can blurt it out, but I can't hear you. It's cordyceps. That's right, cordyceps. This ant here, you can see is biting the stem, and there's this weird growth coming out of it. That's called a zombie ant. That's because there's this fungus that can infect the ant, takes over its brain, and tells it to climb up. And then it tells it to clamp down with its mandibles, because now that fungus is going to take over all motor activity. It's going to sporulate and infect more ants. Here's another one of them bad boy zombie ants. Again, a type of cordyceps. And if you haven't seen the show, The Last of Us, the idea is that these cordyceps evolve in some way to start infecting humans. And now humans can become zombies infected by cordyceps. Kind of a freaky thought. For the sake of time here, I'm going to jump forward a little bit to talk about how there's all kinds of bacteria as well that do all kinds of functions. And of perhaps interest to you, whoever you are, because aphids are everywhere, is that aphids have beneficial bacteria too. There are several different species, some of which that can make them resistant to entomofungal pathogens. There's some that can make them resistant to parasitic wasps, some that help them adapt to heat stress, right? So these bacteria help them do all kinds of things. And so in theoretical papers, you can get populations of aphids that are resistant to parasitic wasps, because if you have very high density of parasitic wasps, you are selecting for aphids with those endosymbionts. Now, in practice, we haven't actually really seen that. So there's maybe some other trade-off happening in the environment. But there's these very interesting bacteria that play this role in aphids. In a similar fashion, we have fungi and bacteria that can help plants. So you can see where I'm maybe headed with this, right, is that trichoderma is probably one of the most well-studied beneficial fungi of plants that can help really strengthen them. Biology and technology of trichoderma, review on plant trichoderma pathogen interactions, biocontrol genes from trichoderma review, so on and so forth. And these studies have cited over 102 studies, meaning these are reviews, right? So they're looking at other studies. They're not doing their own research per se. They're looking at other studies. And this one is 102 studies, all of which have some kind of mention of trichoderma. So very well studied. And our company BioWorks is actually founded on this organism. We'll get to that here in a moment. But when we run a good old chat GPT on summarize kind of what are the main functions of trichoderma and what do they, what does it do? Here's what we get: overcome fungistasis. So trichoderma is resistant to a lot of soil toxins and many fungicides. And that's why if you look at we have a trichoderma called Ruccio Plus, you can actually tank mix it with a lot of fungicides and it's totally fine. So it's kind of this super fungus that grows in many different environments. It does nutrient competition, so actually outcompetes other fungi and other bacteria as a result. It can parasitize other fungi. So when we're talking about Pythium or Phytophthora we talked about earlier, trichoderma can actually go into it and eat it from the inside out. It has these other properties where it can degrade cell walls see, I just repeated this one here, and many others, right? So there's many functions that trichoderma can do based on these studies. And so I'd mentioned Ruccio Plus. That is a dual trichoderma product that we currently sell. It is a patented dual strain, so no one else has this dual strain. And like I mentioned, over 20 years ago, this company was founded. The very first trichoderma commercialized that has been just an incredible product for a lot of growers. It's our flagship that really helps growers prevent a lot of root diseases. So if you're facing root diseases and you're looking for a good preventative program to create strong, robust plants and prevent diseases, you may be considering this Ruccio Plus. And you can see here as an example, right, that Phytophthora that I'd mentioned in those plants, you can see the symptoms are starting to increase in more and more plants. And this is actually the chemical control, so it's weekly applications, versus this is just a sole incorporation of Ruccio Plus granular, and this is about 3 or 4 months later. So it's just one incorporation, nothing else applied to it. So it, again, goes back to the importance of when you first transplant, creating a strong, robust transplant, and then the plant can take care of itself. And that's essentially what's happened here. And we also see Rootio Plus can really help with germination. So with the ranunculus, you can see in this particular study, ranunculus were getting about 43% germination, with Rootio Plus getting about 74% germination. We also see that in crops like celery. These are celery plugs. This is the chemical control. So if you have plugs that are looking a little bit bare and sad like this, a Rootio Plus drench may be the solution that really helps. And again, our biggest motto here at BioWorks is grower success is our success. So we like to see you be successful with our products and help you essentially build strong, robust plants. And Bacillus is another one. Any of you that have studied biocontrol or IPM, you're maybe very familiar with BT, Bacillus thuringiensis. That's probably the original gateway biocontrol, right? That was a bacteria used to kill Lepidoptera. A very successful biological control, continues to be a huge product. But there are several different types of Bacillus species. And so they do all kinds of different functions. For example, they produce antibiotics to actually produce chemical compounds that kill other organisms. They help with plant growth promotion by actually creating specific compounds, including IAA, right? So it actually creates IAA that helps. I know a lot of you might be sticking those cuttings in IAA before you stick them. This particular product, this Bacillus actually creates IAA. It helps with inducing disease resistance in the plants, and it creates weapons out of enzymes as well. So it's got some really neat functions, including, and we've seen it also help with abiotic stresses. So you can see here, this is a plant on the top. You can see plants that are water stressed. Both left and right are equal in their water stress. The one on the left has been treated with our Bacillus product known as cease. Now, if you go down, recovery period, 7 days, you can see the cease treated recovered much better than the non-cease treated. So when we're talking about, post-sale at the retailer location, irrigation practices might not be ideal. Cease treated products are maybe a lot more consistent. So there are a number of growers that apply cease on their crops right before they get on the trailer to really help on the retailer end. But cease is also a great broad spectrum foliar, fungicide, as well as a root drench against a number of pathogens as well. All right. Last, getting into best application methods. And I'm doing a quick time check. Looks like we're okay. All right. So here I'm going to jump into label directions, the right application method, looking at droplet size versus drift, and trying to get good coverage. So on the right side, you can see the things I'm going to run through here. In terms of application method, always make sure you read those labels thoroughly. Can't iterate that enough. I don't think any of us manufacturers can iterate that enough. The number of calls we get where either there was some crop damage done or they didn't get efficacy, and it's often due to the application method. So whether you see fogging, these are very important. Spray to glisten, to wet, or spray to runoff, right? Spray is visibly running off the edges of the foliage of spray to runoff. If a product says spray to glisten, small droplet deposition and sheen on plant surface, no runoff. If you see that on the label, but you're getting runoff, there's a risk there, right? So you want to make sure you're reading that very carefully. We also have a sprench, which is basically a high volume spray that's aimed down to the base of the plant versus a drench. And then we also want to always make sure that our product is getting into the injection. So we can do that with a simple dye. This was a demonstration we did at a grower location to show how long does it take from the time of injection to actually get to the different points of their injection line. And the purpose we want to do this is make sure that when we are injecting, if we're injecting for 10, 20 minutes, we want to make sure that by the end of that 20 minutes, that injection has already made it to the plants in the furthest corner on the furthest end, that they are getting the same amount of injection material as the rest of the plants. So that's very important. Then we maintain agitation. So depending on the product, some things require agitation. A lot of biologicals, those spores are a little bit heavier, can start to settle. In this case, we're talking about nematodes. Nematodes will also settle, so it requires a certain level of agitation. and also monitoring the PSI. So some products will require a specific PSI or mesh size to make sure the product can flow through and they aren't decimating whatever organisms in there while it's being applied. And then read the label for a specific application method for a specific crop and pest. We have tried to make that very easy for our particular products. If you go to bioworksinc.com, under resources, you will find 3 tools: application methods, which makes the application method part very easy for all of our products. We also have an application rate calculator. Here you can see all of our products. You can select the one that you're trying to apply. The number of calls I still get saying, hey, this says, how much do I apply per 100 gallons? How much do I mix into 5 gallons? This rate calculator really helps with that. All right, so go to the product. What is your application type? And then what is, in this case, your volume of soil that you're applying root plus granules to. And you can even change the units. Maybe you want it in cubic feet. And that'll then tell you the exact range of which to apply the product at. And the same thing for cease. You can see for fogging, you can select auto fog, what type of material it is, and then the area that's being treated. You can do it in square feet, acres, whatever you want to do. And it'll tell you the amount of product and the amount of water, recommended water to mix it in. And when we get into coverage, again, make sure you look at usually under the product information part of the label. So for example, our product Sulfoil X will say that use enough spray solution to completely penetrate the leaf canopy and cover both top and bottom of all the leaves till wet without significant runoff. So that means you can have some runoff, but if there's a lot of runoff, this product, being oil-based, can be problematic. Talus, a product that is not ours, but is a different type of application coverage, you can see apply the specific dosage as a foliar spray and sufficient water for complete uniform coverage, including stems and underside leaves, spray to the point of runoff. So in this case, it's kind of a different language, but very similar end message. You want to spray just until it starts to run off, not plenty of runoff. And then check your coverage with water-sensitive paper, and we will get that, and we'll talk about that in a little bit more detail here in a bit. Always look at those storage conditions. They'll tell you at what temperature you can store the product and for how long, so that it stays effective. And that's very, very important for maintaining efficacy of your product. And then in terms of tank mixing, make sure you're looking at that label as well. Sometimes it'll say, do not use with this product or that product. A lot of oils will say, do not spray after sulfur use, because that can actually trap the sulfur between the oil and the plant, and that becomes a gaseous layer, essentially, that can really hurt the plant. All right, so pay close attention to what it says in terms of compatibility on that label. It'll tell you sometimes the specific compounds. So again, make sure you pay attention to those. Now we have, again, a tool on our website to make things really easy is our compatibility tool. Again, bioworksinc.com, go to resources, you'll see this compatibility button on the top right, and you can put in our product name and any other product. We've tested a lot of different things, or the active ingredients of the other product instead of the trade name, and you'll usually get something about their compatibility together. If there is no data there, let us know. And if it's something that's asked about frequently, we will run the test ourselves and make sure that they are compatible. And then also check the pH instructions. So some products will say, make sure the pH is between, in this case, 4.5 and 8.5, which is a pretty broad range. But there are some others that might say, do not adjust the spray solution pH. And some of you might actually be putting in some pH adjusters in there. And as an example, our product Millstop, which relies on increasing the pH, the product increases the pH, and that's a part of its activity. By actually adjusting that, you're going to get rid of the efficacy of the product. And also be aware that changing the pH can also impact how long that active ingredient lasts, say, in the tank. So as an example, as you start to increase pH, you can see there at the top of that table, pH 6, 7, 8, and 9. And then below pesticide is the active ingredient, and it's how long the half-life is. So how long does it take for half of that ingredient to degrade into other compounds that are likely not efficacious or have some kind of other impact? And so we look at Captan, which is the second one. You can see the pH of 7, it'll last 8 hours. pH of 8, so if you're using it with Millstop, right, it's got 10 minutes in that tank before half of it's gone, another 10 minutes until another half of it's gone, so on and so forth. So you want to pay close attention to that pH, as that can then really impact the efficacy of your product. All right, so then the last topic here is droplet size. So, if you look at these 3 different droplet sizes, when we're talking about application, you'll see on the far left, 1 droplet that's 100 micrometers in diameter is equivalent in volume, right, like water volume or content volume, as 8 droplets that are 50 micrometers, which is equivalent to 1,005 droplets that are 10 micrometers in diameter. And this is a principle that we learned from DRAM. DRAM is a great pesticide equipment manufacturer. Highly recommend checking them out. They really understand good coverage, droplet sizes, how to get consistent droplet sizes, penetration and diffusion into a plant canopy. Anyway, so when you look at these 3 and why it's important to get a smaller droplet size, if now we start looking at coverage, right? So that 10 micrometer, that droplet on the left, only covers that 10 micrometer diameter area. Whereas if you go to the right, where we have the smaller droplets, it covers a much greater area, and it's a much more even coverage. So if we look at applying these droplet sizes to, let's say, whiteflies, you'll notice that big droplet that's almost in the middle, right? That's the large droplet, which would have missed the whitefly. High chance of missing the whiteflies. If you go to the next smaller, yeah, there's a higher chance of hitting the whiteflies, but you can see there's not a whole lot of droplets, and those could be different areas on that particular leaf. But if you go to that smallest droplet size, that whitefly is not making it out of there, right? So that's really providing very good coverage. And there's an excellent resource if you go to this QR code through the Pesticide Environmental Stewardship that really talks about the trade-off between going very fine in droplet size, and you have increase in drift, versus very coarse. And you really want to, if you're outside, especially on a windy day, you're spraying something, you want to make sure it stays on the crop. You don't want to go too fine, because then those droplets are just going to stay suspended in the air rather than landing down on the crop. There's a number of different types of applicators that can get you very fine and consistent droplets. And that includes hydraulic sprayers, which can be like a backpack or a pressurized hand pump or a handheld gun or boom. We also have low volume mist. Now, these are considered almost like dry applicators at this point already. We're getting very fine spray applications. A lot of oils at this and going to ultra low volume are not really recommended, because at that point, you're actually not getting the wet coverage you need on the insects to kill them. Oh, man, it looks like we got something moved here. I'm just bouncing right back. All right. Going on to now improving your technique and making sure you get good, even coverage. We want to use, I highly recommend using water-sensitive spray cards. So if you get these spray cards and you clip them into the canopy, you have your applicator go through, you'll get a good idea. You'll see here on the left, that water-sensitive card, anywhere a droplet falls, it turns blue. You'll see on the left side, not enough coverage. On the middle, it's pretty good, even coverage. And on the right side is way too much. If you're getting stuff like that, that means you're getting just runoff, smudging everywhere, rather than getting very good coverage. And if you want to really nerd or geek out on coverage, there's a software called Fiji software. We'll actually measure, count all your droplets and give you your droplets per inch, but also tell you how even your droplet sizes are. Because if you're getting some big blotches and some small drops, then that's also not a particular great applicator. So that concludes kind of going over the best plant sanitation and cultural practices, how to promote your healthy plants, and lastly, best pesticide application practices to hopefully lay out a strong IPM program. Thank you so much for listening in.
All right. Thank you so much. I hope everybody can hear me. And we do have a lot of questions, so please, you can send in some more. We have about 10 minutes, so we'll get to as many as we can. The first question do you remember which slide the QR codes are on? One of the viewers would like to see those again. And I'm sorry, that was me.
Which ones? There were a few. So here's one that's looking for identification. Oh, sorry, go ahead, Robin.
No, I was just going to say, she did not say. So
She did not say. So
no.
here are some of the QR codes for identification. You can snap some quick pictures with your phone and you can scan them later. Or you can come back and watch the recording to catch them. And then there was another one, let's see here later on, which was a review paper. Here we go for the protein hydrolysates.
Okay. Thank you. Okay,
Yeah,
so
no problem.
you can leave that up there for a minute if while I ask the first.
I'll leave it up for a minute and I'll go back to my contact information.
Yes.
Yep.
Yes. This one is why are California and other states banning perfectly safe biocontrols? How can we help change that to allow more biocontrols as this person believes the current mode of thinking is completely wrong?
Sure. It always helps to speak to your state legislators. Look, as the growers, especially large number of growers, or if you're a large grower, you actually have a lot of influence, especially in a state like California where production is such a big part of that state. What you say really matters. And so, I'd say, speak to your state legislators, speak to your state departments of ag to try and really help you get the tools that you need to be effective at producing in your area. Let them know what your challenges are.
Okay. All right. Our next question is, do you use On Guard with fertilizer, or do you use it instead of a fertilizer?
You can, yes. So the first step would be to optimize your fertilizer rate, right? To determine, are you using too much? So you can do some testing with that. Once you've found kind of the optimal rate, you can then introduce On Guard with it. On Guard is a 500, but it's not highly available nitrogen. Again, it's more amino acids and these hydrolysates, these peptides that help promote other elements. And you might find that then you can further decrease your fertilizer if you were to re-optimize, because now it helps with nutrient uptake efficiency. So in many instances, we recommend using it with, because all that is a, again, 500, and it's not immediately available.
Okay. All right. Our next viewer wants to know, would you recommend EpiShield or Sofoil for dipping cuttings in external sources? For dipping cuttings from external sources.
I'm sorry, I lost you there just for a moment, Robin. Could you mention that again?
Yeah. Would you recommend EpiShield or Sofoil for dipping cuttings from external sources? That's number 15 down there.
So Sofoil, it depends on where you're calling from. Sofoil X in the broad US is not labeled for dipping. If you're calling from Canada, it is. And so Sofoil X is and EpiShield are going to work pretty similarly as dips. They're going to have slightly different phytotoxicity profiles, let's say, but at that initial stage where they're not flowering, they're both pretty safe. We always recommend testing initially to make sure it's okay. The Sofoil X does have a restricted entry interval. So when you do that dip, you still do need to wait 4 hours before you can then stick it, whereas your EpiShield does not. So it has that major benefit. So it really just depends on what you're looking for. EpiShield, again, you just want to make sure that you're doing some quick tests to make sure that whatever crop, cultivar, and environment you're working in is going to be okay for dipping into EpiShield.
Okay. All right. I know we talked about whiteflies on poinsettias a little bit. Someone would like to know, just like it says, they usually get whiteflies on their poinsettias and they want to get ahead of them this year. What can we do to control them? So overall program, I guess, as far as
sure.
Your experience.
Look, there's a number of strategies, and it depends on how involved you want to get into the best management practice. So there's, I've published a paper on IPM in poinsettias that actually looks at using a combination of beneficial insects, so predatory mites and parasitic wasps, can work very well in a preventative program. So the time of sticking, start using those two, and then you're going to do spot spray treatments or applications of things like Rycar, Principal, like I just mentioned, Moltex, which is an azadirachtin, to maintain low populations. But essentially, you would be really having a strong beneficial insect program to start with. If you don't want to be as involved, right? So the beneficial insects, they're really easy to release, but they involve, I don't know, is a little bit more nuanced than spraying a pesticide. So on the other hand is then just having a strong rotation program. Be familiar with both the MEM1 and MED whiteflies that are resistant to different insecticides. Make sure you're spraying things that are going to work on both of those two different subspecies.
How would they know? This is me asking. How would they know if they had one of those two species?
So they're fully cryptic. So you actually, so testing it, you could send it there. I know there's a lab in Florida that tests, but it has to be done by either molecular analysis, or if you want to spray, you've got some pyriproxyfen and you want to spray that on your whiteflies. If they die, then it's the one. If they don't die, it's the other. So that's one way of telling. Yeah.
Okay. All right. So let's see. You mentioned how over-fertilization can promote spider mite populations. So how do they know if they're over-fertilizing?
Yeah, so I think that goes back to optimizing. So that might be growing a few crops at the same time, trial crops, as the one you're doing your regular fertilizer regime at 80%, 70%, maybe down to 50% of what your current fertilizer regime is, and just seeing if there's any impact on plant growth. If the plant growth is the same flowers, same number, same size, everything, then you're over-fertilizing and you could probably decrease that.
Okay. Save money and reduce the spider mites at the same time.
Absolutely. Exactly.
All right. Here's someone would like to know, where can we buy Principal WP?
Sure. We have a number of, so we work through distribution. So we have a number of channel partners that are very close and dear to us that we work very closely with. If you go to our website, bioworksinc.com, you'll see a tab at the top that says where to buy. You click that, click your state or where you're located, and it'll show you the list of channel partners that we work with.
Okay. This next question is not really a question. It's more of a statement. And you can just say if you agree with it. New biopesticide labels may have droplet size requirements as part of their drift mitigation language that's required by EPA.
There are drift mitigation requirements on labels going forward. So yes, there's a lot of that on there.
Okay. And I'm going to put one more question out there, and then we're going to have to wrap up. And it is biostimulants and products that claim a mode of action that affects metabolism are considered plant growth regulators and not regulated by EPA. They're not eligible to be registered as fertilizers. Again, more of a statement, not a question.
Yeah, so it's right now kind of that a bit of a gray area. I know EPA is getting closer to defining a biostimulant, which quite frankly gets us excited, because once there's a solid definition and maybe some process around it, there's a lot of biostimulants out there that make a lot of claims, but currently there is no process to check those claims. So if there was some kind of a process, then we could at least demonstrate that our product isn't just another one in this like sea of things that are called biostimulants. It's actually, it's got some data behind it, but it's also been accepted by regulators. So that's absolutely correct, that statement. But we're hopeful that we're moving in the right direction.
Yeah, I think that'll help everybody trust that the products are actually what they say they're going to do when it's sort of formalized like that.
Yep, exactly.
All right. Well, I have to close down the questions. If you did not get your question answered, I'm sure Dr. Vafaie will follow up with you. We have your email, and we can follow up with you in the next week or so. But I want to thank everybody for attending today and for giving us your time. An on-demand version of this webinar will be archived in the next few hours, and you can use the same link to get to it that you used to get on today. And you'll also get a link tomorrow in your email about this time of day that'll tell you how to watch the on-demand version again. For those of you who want credit and responded to the attendance notification for the CEU credit, please do not close your browser window before the event's fully ended, or you won't get the email with the QR code. So that's pretty important. That is also for the viewers that are watching the archived version as well. So again, thank you for excellent information, and thank you all for joining us today. And thank you to BioWorks for making the webinar possible. We really appreciate your time, and have a great day.
Our pleasure. Thank you so much, Robin, and thank you everyone for watching.